In this video, we discussed about the arithmetic instruction of 8085 microprocessor. These instructions perform the operations like addition, subtraction, increment and decrement. Addition. These instruction is used to add the content of register or content of memory or 8-bit number to the content of accumulator. The result is stored in the accumulator. No two other 8-bit register can be added directly. For example, the content of register B cannot be added directly to the content of register C. Add register or memory to the accumulator. After the execution of this instruction, the content of register or memory are added to the content of accumulator. The result is stored in accumulator. If the operand is memory location, then the address is specified by the HL pair. For example, at C, the content of accumulator is added to the content of register C, and after execution of this instruction, the result is stored in the accumulator. And for add M, the content of accumulator is added to the content of memory location which is specified by the HL pair, and after execution of this instruction, the result is stored in the accumulator. This instruction is used to add the content of register or memory to the accumulator with carry, and the result is stored in the accumulator. And again, if the operand is memory location, then the address is specified by the HL pair. After the execution of this instruction, all the flags are modified to reflect the result of the addition. For example, instruction add C. After the execution of this instruction, the content of carry flag, content of accumulator and the content of register C is added, and the result is stored in the accumulator. For instruction add memory with carry, after execution of this instruction, the content of accumulator, the content of carry flag and the content of memory location specified by the HL pair are added, and the result is stored in the accumulator. Next, ADI. This instruction add immediate to the accumulator. That is, the 8-bit data is directly added to the content of accumulator, and again the result is stored in the accumulator, and the flag are modified to reflect the result of addition. For example, ADI 05. After execution of this instruction, the content of accumulator is added to the 8-bit data 05 directly, and the result is stored in the accumulator. ACI. This instruction is used to add immediate to the accumulator with carry, that is, the content of carry flag and 8-bit data added to the content of accumulator. Again, the result is stored in the accumulator, and the flag are set according to the result of addition. For example, ACI 20H. After execution of this instruction, the content of accumulator is added to the 8-bit data with carry flag and the result is stored in the accumulator. DAD instruction. This instruction is used to add 16-bit data with the content of HL pair. That is, the 16-bit data stored in a register is added to the content of HL pair and the result is stored in the HL pair. If the result is larger than the 8-bit data, then the carry flag is set and other flags are unchanged. For example, DAD D. After execution of this instruction, the content of 16-bit data of D pair is added to the content of HL pair data, and after execution the result is stored in the HL pair. Now the subtraction. Like addition, the subtraction is also performed with the accumulator and no two other 8-bit register can be subtracted directly. Subtraction is performed in 2's complement form, and if the result is negative, then it is stored in 2's complement form. Like sub. Sub instruction is used to subtract register or memory from the accumulator. That is, the content of the register or memory location are subtracted from the content of accumulator and the result is stored in the accumulator. And if the operand is again a memory location, then it is specified by the HL pair. And all the flags are modified according to the result of subtraction. For example, sub C. After execution of this instruction, the content of accumulator is subtracted by the content of register C and the result of subtraction is stored in accumulator. Next, sub M. Here again, the content of accumulator is subtracted by the content of memory location which is specified by the HL pair and the result is again stored in the accumulator. This instruction is used to subtract register or memory from accumulator with borrow. That is, the content of register or memory location and borrow flag are subtracted from the content of accumulator and the result is again stored in the accumulator. And again, if the operand is memory location, then the address is specified by the HL pair. For example, sub C. After execution of this instruction, the content of accumulator is subtracted by the content of register C and carry flag and the result is stored in the accumulator. Next, sub M. Again, the content of accumulator is subtracted by the content of memory location specified by the HL pair and the content of carry flag, and also the result is stored in the accumulator. SUI, that is, subtract immediate from the accumulator. This is 1-byte instruction. That is, the data is subtracted from the content of accumulator and the result is stored in the accumulator. All the flags are modified to reflect the result of subtraction. For example, SUI 05, that is, the content of accumulator is subtracted directly to the 8-bit data and the result is stored in the accumulator. SBI. This instruction is used to subtract immediate from the accumulator with borrow. The 8-bit data and the borrow flag is subtracted from the content of accumulator and the result is again stored in the accumulator. For example, SBI 20, that is, the data is subtracted from the accumulator and also carry is subtracted from the accumulator and the result is stored in the accumulator. Next is the increment and decrement type instructions. The 8-bit content of the register or memory location can be incremented or decremented by 1. Also, the 16-bit content of the register pair can be incremented and decremented by the 1. The increment and decrement can be performed on any register or memory location. And after increment and decrement, the result is stored itself location. INR. This instruction is used to increment register or memory by 1. That is, the content of register or memory location are incremented by 1. The result is stored in the same place. And again, if the operand is memory location, its address is specified by the content of HL pair. For example, increment B. After execution of this instruction, the content of register B is incremented by 1 and is stored in the B register. Increment M, that is, the content of memory location is specified by the HL pair is incremented by the 1 and it is stored the same memory location. INX. This is used to increment the data of register pair. The content of register pair are incremented by 1 and the result is stored in the same place. For example, INXH. After execution of this instruction, the content of HL pair register is incremented by 1 and the result is stored in the HL pair. DCR. This is used to decrement the register or memory by 1. The content of register or memory location are decremented by 1 and the result is stored in the same place. For example, decrement C. After execution of this instruction, the content of register E is decremented by 1 and for DCRM, the content of memory location specified by HL pair is decremented by 1 and is stored at the same memory location. DCX. Decrement register pair by 1. This is used to decrement the content of register pair like HL pair, BC pair or DE pair. For example, DCXH, that is, it decrement the content of HL pair by 1. The content of L register is decrement by 1. So these are the arithmetic instructions which is used for 8085 microprocessor operations. In the next lecture, we discussed about the logical instruction of 8085 microprocessor. Thank you.